Hello, Michael. Well, here we are. We're going to have that whirlwind tour of Statistician 2.0. So we'll start by clicking the Statistician tab in Excel. And for this demonstration, I'm going to define a few data variables again. As we did previously, we click the Manage Data form. I want to import some data variables. So, for example, I can import a single variable x simply by highlighting the area. Clicking OK, and now we can see that I have a data variable called x with 10 observations. I can also import a whole group of variables at one time by highlighting the area. So here I have 4 variables called group 1 to group 4 with 20 observations each. I can even import data variables which have text. Sorry, that's my dog. He just saw another cat run out the front door. We'll continue nonetheless. So I've got this data variable called animals. I'll click import and I'll import this text. You might be wondering why anyone would want to import text into a statistics package, but actually quite often on questionnaires people might answer yes, no, maybe, what have you, and you can actually do statistical analysis on text, depending of course on the type of test you're doing. We can also import, for example, a very big variable. This has got 1001 observations, so I click import data variables, highlight the first the name of the data variable, hold down shift and then click end down arrow. That highlights the whole area. I click OK, and in a flash this data variable has been defined. Now all of this data is, as was mentioned, held in a hidden worksheet that the user does not have access to, excepting through the Manage Data form. I now close this. I'll go back to the top of my worksheet and we'll have a look at what we can do after we define data variables. Firstly, we've got this pull-down menu called Tools. And this is just a handy collection of various sorts of tools that we might wish to use. We saw summary statistics previously. For example, it's also got statistical tables. Quite often in undergraduate statistics courses, a student might want to have a look at a probability distribution. So we can actually print that straight out into the worksheet. So say we might wish to print out the normal distribution. I'll click output, highlight a cell, click OK, and in a moment we're off, and here is the normal distribution found in all introductory student textbooks on statistics. A few other tools. Sort and rank, sampling, optimize is an interesting thing. This is kind of a mini version of Excel Solver. It optimizes one cell by varying a range of other cells. I guess it's different because it's a lot simpler and it actually is a bit slower, which might seem to be a negative, but actually the optimization routines that I use within this are highly robust to badly behaved data, if you like. And it will find global minimums and global maximums that sometimes Solver can't even find because of the inbuilt routines in Solver. So I just kind of threw this in with it with Statistician just to add a little something, if you like, to the package. We also often do standard tests in statistics to see whether a data variable is equal to a particular value, whether two data variables have the same mean or average, or the same mean or proportion, so on. We'll just quickly have a look at one of those. Difference in means for independent samples. So I choose two different data variables and I see whether the mean of one minus the mean of the other equals 0, for example. So I'll choose data variable group 1 and test whether that's different from data variable group 2, the mean. The alternative hypothesis stated. I could output a confidence interval, a 95% confidence interval for the difference of the mean. I could choose how many significant digits I might want in my output, say 3 significant digits. I can make some assumptions about the standard deviation of this difference, whether they're unknown and unequal, or whether they're known and unequal, or unknown and equal, whatever. I'll choose unknown and equal just for something to choose. I can output an F-test to test whether the variance of both of those data variables are equal. I choose the significance of the test. I'll choose 1% in this case. I'll then output my results somewhere in the worksheet, and in a flash we have the output. I want to make a couple of points about the output, which is unique not just amongst Excel add-ins that do statistics. I would put it as pretty unique against almost every statistical package out there, and that is the readability of the output. What you see too often is output which is a whole lot of very cryptic numbers, hard to interpret, poorly labelled, and the poor old students and researchers spend a lot of time trying to work out exactly what numbers they have in front of them. And so what we do here with Statistician is actually all statistical tests are basically a null hypothesis and an alternative hypothesis, and you look for statistical evidence to either reject or not reject the null hypothesis. So I actually write it out. The mean of group 1 minus the mean of group 2 equals 0, which means the mean of them is equal to 0. So we'll test that hypothesis. I offer some brief sample statistics here. The difference in the means. Then a number of statistics relevant to such a test. The t-statistic with 38 degrees of freedom, the critical value of whether to accept or reject that particular hypothesis, the alpha, the probability of making a type 1 error, the p-value of that test. I then actually write out what the decision rule is for this test. Reject the null hypothesis if the absolute value of the t-statistic is greater than 2.7116 or the p-value is less than 0.01. If I have a look at the t-statistics, it's negative 0.33, so it's not greater than 2.7. I will not be able to reject the null hypothesis, and I actually write that out. Conclusion: do not reject the null hypothesis. That helps people enormously, I find, just the readability of the output. We then have a lot of other things. We had an extra test. Remember, I added in I want to test whether the variance of group 1 is equal to the variance of group 2, those two data variables. Again, a whole lot of stats come out, but again we conclude I can't reject that they have an equal variance. Oops, okay. So that's all part of our standard test. We have a number of variance tests, not just the simple F-tests that we saw, but some quite sophisticated tests. We have a Levine test, and again, like every form in Statistician, I choose a data variable. I then decide various specifications of the output that I want, and then tell it to output the result somewhere. I won't do that right now. We have a whole lot of tests to see whether two distributions are normally distributed or not, whether a data variable is normally distributed. So I select a data variable and run my test. I won't do that now. Again, a whole lot of different forms to do all these non-parametric tests, and again nothing changes. The forms, I'll just select one at random. I put the name of a data variable, choose the data variable in a group 1, for example. I want to test whether the distribution of group 1 is equal to the distribution of group 2. Again, I have choices about the significance of the test. I might check I want to output cumulative probabilities, and then I can output them. I won't bother at the moment, so I'll just exit out of there. We can do multinomial tests, we can do contingency tables. We looked at regression analysis in the previous video. We can do binary models, we can do count models. Binary models are basically logit and probit models. that require some very sophisticated machinery in the background to actually estimate the parameters of these models. Some very difficult optimization problems with some quite complicated functions to actually get the output. We can do cluster analysis, principal component analysis. We have a whole lot of time series routines. Holt-Winters is an interesting one because that one, I'll do a time series of one of the group 3 for example. I'll estimate just a simple Holt-Winters model for group 3. That's a time series. We normally pick a damping factor to smooth out the time series, and then we normally wish to forecast out from that. I'll output the results. Here I'll make a bit of room on my worksheet to output the results here. So here we have the results. What's different about Holt-Winters is that the output isn't just text and numbers. In this particular case, we can see that the output is actually a formula. And so we don't do that a lot in Statistician 2.0, mostly because you can't do it on a huge range of these tests. But when you can simply add in a formula, we do, because it just makes everything far more readable. I'm not sure I can add a whole lot more. We've got a little about button to tell everyone what version we're using. I've got an activate button. I'm using the full version, but people typically download the light version from our website, and then they activate it by typing in a code after they've purchased the code through PayPal. You can contact us, which will just bring us to our particular website. I'll go home to that. That's the contact page. So that's Statistician, powerful fast stats. I don't know how much I've added to the previous video, Michael, but I hope it helps a bit at least. All the best, and thank you.